Ladies and gentlemen of Algebra 2 Honors, good afternoon. Good to have everybody here today. Before class, Marcus, who is not here today, asked a question about what went on in class yesterday. And I explained that we worked on solving systems by elimination. Basically where you add equations together to eliminate variables. In this case, if these two equations are added together, you will end up getting 3x and then 3y minus 3y is 0. So you eliminate essentially this y variable, and then you gradually distill from there. So that's what we worked on yesterday. Today we're going to work on all three types of solving, including we're going to introduce something called matrices toward the end of class. So right now on number 1 it says solve the system using substitution. So we're going to work on substitution, and if we have time, elimination, and definitely get to matrices by the end of class. Okay, how would you look at solving this first system by substitution? What would be your first step on this?
You add the top equation in the middle.
Could you do
Okay.
the bottom one? What's the first one? Add 2y to both sides on the very bottom.
Yeah, so what Abigail and Gabby said, okay, is probably what I would do. Because if we add 2y, is that what you said, Gabby, also?
Yes, sir.
So x is equal to 2y. Okay, so that's really a great first step. And we had a student in 7th period who suggested solving for y first. But I'm really thinking a better move would be, as you young lady suggested here. Okay? Good job. But it's really, there's a lot of your own initiative and judgment you have in this. And if you still can get it done, do it. So now we're going to go ahead and take this top one and use that x solved for. And by the way, these numbers here are just the numbers of the equations, like 1, 2, 3. So I'm just going to blot those out. They're not important to the solution. So we have, in the place of x, we have 4y. So 4 times 2y, excuse me, 4 times 2y plus y minus 2z is equal to -6. Does that make sense pretty well? Okay. And don't hesitate to stop me if I make a mistake or if there's something you don't understand here. And continuing to work to the right, what we have here is 4 times 2y, that's going to be 8y, so that's 8y, and then we have plus y, that's going to be 8y plus y, that's going to be 9y, right? So I'm just going to write 9y here, and then minus 2z is equal to -6. So there's one equation with x substituted out of it, or substituted out, yes. And now this one right here, right below, we're going to have 2 times 2y minus 3y plus 3z is equal to 9. And continuing to work to the right, we have 4y minus 3y is going to be y. And then we have plus 3z is equal to 9. Okay? Is that pretty well? Is that what you've said? Did anybody work ahead of me on this a little bit? You did a little bit? Okay. Good. But now, what do you think our substitution step would be on this one? I want to get not Abigail, not Gabby, but somebody else. What would be a next substitution move on this?
Y equals subtracting 3z, so we'll get 2 2y for every x.
Yeah, so what I'm going to do here is what Ben suggested here is this. If you go ahead and make that subtraction, y is equal to 9 minus 3z. Is that what you meant, Ben? Yeah. So now we have that, and so what can we do with that now? Well, I'll show you what we can do. We can take this equation here, right? This 9, well, what is y equal to? 9 minus 3z. Thank you, Kim. And then we just bring over what we have left here, which is minus 2z is equal to negative 6. Does everybody see that so far? Anybody not see that? You're not seeing it? You are seeing it?
No, I don't understand nothing.
Okay. Okay, I'm sorry about that. I don't know what to,
Right now.
I don't know what to do. Okay, then we have 9 times 9, which is 81. And what's 9 times negative 3?
27.
Negative 27 z minus 2z equals negative 6. Okay, do we have like terms over here? So negative 27 minus 2 is 29, right? Or negative 29, excuse me, right? And then what?
Subtract 81.
Subtract 81. So we have negative 29z and negative 6 minus 81,
Negative 37.
negative 87. And then we divide by negative 29. What do we get? 3, right? So we have z is equal to 3. Now, when I start doing this, and I start seeing these numbers get big, that makes me kind of nervous. Why should that make me nervous?
They're big numbers.
Because one, they're big numbers, and maybe I won't be able to do the arithmetic very easily. But secondly, what if the thing doesn't divide out to a fraction or some kind of weird decimal? But in this case, it went out to 3, and so that's what
So
that is.
it's always going to be a whole number, or no, it's not?
No, it is not necessarily always a whole number, okay? That's one thing. Now, in most of the problems that I will give you at this level in this class, it'll be a whole number or some fraction that'll be like 1/4, 1/2, 3/4 as a final answer, usually. Like, I had a couple mistakes in some of the exercises I prepared yesterday, so I went and fixed those last night. Because they didn't work out right, I might have made a mistake. But anyway, so now can we find out what x is?
Yes. Well,
Or, no, we can find what y is though, right?
yeah.
So for y, we're going to say y is equal to 9 minus 3, and z is 3, right? So 9 minus 9, y is equal to 0. And now can we find out what x is?
Yep.
Yeah, so x is equal to 2 times 0, so x is equal to 0. And so therefore our coordinate triple
Zero.
is the point 0, 0, 3. Okay, so that's going to be our answer to this one. And then quickly we can check by plugging back in to the original equation. Well, x and y are 0, right? So we just have negative 2 times 3 is negative 6, right? And 3 times 3 is 9. And here, the last equation is 0 equals 0. So that's a good solution, right? What I want you to do is to similarly try to work with problem 2 and just work through that for a while. I will tell you with problem 2, that there will be fractions in a couple of the answers, at least. So just be aware of that. It shouldn't affect how you solve it. It'll just be that final division will give you a fraction, I will say. Just work on that for a little bit, and I'll come around and you may help each other with this. That'll be good. Where do you think you would start with this one here?
And,
Is the 4y minus z.
Yeah, the 4y minus z I would do. So what you'd get z equals 4y minus 3.
Wouldn't it be
With negative z?
Negative z?
Yeah, but you subtract the negative off of the z, and it'd be positive, it'd be 4y minus 3.
Yeah, so I will show you this because Connor's still asking a good question. What happens is, you got this 4y minus z. See that, Connor? So you take that negative z, move it over here, it becomes positive, and take this 3 over here, it makes it negative. So you have z equals 4y minus 3. You see that? So that's what that was.
Yeah.
Well, Connor's doing good.
Yeah, doing great here.
He is. Okay, this is what I got with these two equations with substituted in. Does that look right? Did I make a mistake there?
That's pretty good to me.
You see what I did? You have hesitation on that?
Yeah, I think
So here, right here, you have 5y plus 12y, so that's going to be 12. And then you have 3 times negative 3, that's going to be negative 9. And you add that to 4 on the other side. So that's where that 13 comes from. And here, this other one, you got 16y minus 2y, that's where that 14y comes from. And then you have this 4, that's a 4 here, times negative 3, that's negative 12. And on the other side, that shows up as 12. Does that make sense? Yes, Marcus?
How does Z become a positive if you never move it over?
How does z become positive?
Yeah, because it's negative Z, but then it's
That's what I'm
positive.
talking about. More.
Because you subtract 4y, so it'd be z equals negative 4y plus 3, but then you divide it all by negative 1, so it'd be z equals 4y minus 3.
Yeah, so what it is, Abigail explained it, I think, pretty well, but what happens is, whenever you take a variable or a number and put it on the other side, the equal sign, you change the signs of it. So this negative z over here shows up as positive z, and this 3 that's positive over here will show up on the other side as negative.
You just flip, okay, now that makes sense.
Yeah, okay. And what it is, it's sort of an algebra technique. You get used to doing that. You cross the equal sign, change the sign of the thing. So it's just something, and to me it helps on something like this where you might have a lot of writing to do. It'll save a lot of space perhaps. So that was a good question, Marcus. Okay, what's going to be your next strategy on this one, you think? What would you solve for here between these two to substitute?
Would you do both?
No, I didn't say anything, I got confused, I just stopped. I have nothing written.
Price, yes.
The top equation,
Yes.
subtract 17y plus that?
Yes, I would subtract 17y. So would you have, you'd have x equals like negative 17y plus 13. And now how could you use this equation here? Replace this x here, right? So we have 6, and in place of x, we put negative 17y plus 13. And then we have this plus 14y, right? And that's going to be equal to 12 on the right side. And just start simplifying. 6 times negative 17 is? Okay, so it's going to be 6 times 10. What's 6 times 10? 60.
102, negative 100.
And then 6 times 7 is 42. 60 plus 42, 102. So we got negative 102 y. And then we're going to have the 6 times 13 is going to be 78. So plus 78 plus 14y is equal to 12. And then combining these like terms, the y's, is that going to be what, negative 88? So negative 88 y plus 78 is equal to 12. And then subtract 78. So we get negative 88y equals negative 66. Is that right?
Yes.
Then divide out what is y going to be equal to? 3/4. Now, to me, this is not really working with fractions that much because we just came up with a fraction at the very last, right? So to me, it shouldn't have been that tedious, but now what can we do that we have y is equal to 3/4?
Plug in the little one into that thing.
Plug into the middle.
And this one here?
Exactly.
Yeah, so let's do that. So we have x equals negative 17 times 3/4. And then we have plus 13. How many fourths do we have in 13? 13 is how many fourths? 13 times 4.
82.
52. All right, thank you, Jay.
Oh, I was only a plus instead of.
So what we have is x is equal to negative 51 fourths plus 52 fourths, which is
103/4. Divide that.
negative 51 plus 52,
103. Or no, 1.
1/4. And so that's that. And so we just need z, right? So z is going to be equal to 4 times y, which is 3/4, minus 3, right? What's 4 times 3/4? 3.
3.
So we have 3 minus 3, so z is equal to
0.
0. Okay, so we got put into fractions a little bit. How many of you got this? Did you get it? Everybody get close to it?
I got
Not even close.
I got
It's so
Z.
confusing.
I found Z.
You got z?
Yeah.
Okay, well, good. To me, this one, for second problem, is a little bit, because it comes into fractions a little bit. All right, what I want to do with the rest of class is I want to kind of skip ahead to problem 6 and really talk about matrices. And you're going to have to trust me that I'm doing this with a good purpose, okay, because it might get a little tedious. We're going to talk about, does anybody know what a matrix is, or what matrices are? What matrices are, they are a rewriting of equations with just numbers. And so this top equation here, the left side of it anyway, can be rewritten with coefficients only as 4, 1, negative 2. You see that? And then the second row is going to be 2, negative 3, 3. And finally, this bottom row is going to be 1x, negative 2y, plus 0z. And what happens is, this is going to be equal to what we call a 1 by 3 matrix of negative 6, 9, 0. And this is called a matrix equation. And matrices were invented, I think, by the Chinese some 2,000 years ago, or 1,500 years ago, or a long, long time ago. And so this is bringing to. And then what we're going to do is condense this matrix equation into another matrix that is going to be 4, 1, negative 2, and negative 6. And then 2, negative 3, 3, and 9. And the last row is going to be 1, negative 2, 0, 0. And I'm going to, usually you'll see these matrices boxed off on each side in this kind of a bracket. And this one on the right is what we call an augmented matrix. And also we call this not only an augmented matrix, but we call this a 3 by 4 matrix. So 3 by 4 matrix is what we call this. And the 3 refers to the number of rows, and the 4 refers to the number of columns. So it's a graphical representation of a system of equations. And what I'm going to do for most of the rest of class now is I'm going to show you the manipulation of the matrices here to get to what we call this kind of form. The final form, when we finish the augmentation, the distillate of the matrix is going to be this. We're going to get these numbers as our answer and the ones across the diagonal, and then we're going to have constants that are A, B, and C. So our answer is going to be x equals A, whatever that turns out to be, y equals B, and z equals C. And so we're going to do the manipulation to get this in this form, and this is called reduced row echelon form. It's called echelon form. And sometimes you're going to see this as RREF. RREF stands for reduced row echelon form. Okay? And I promise you that it's going to make a lot more sense tomorrow than it does today. Do you have any questions besides that right now? Okay, the next thing I'm going to do is do the manipulations to get this matrix into reduced row echelon form. So you're going to be introduced into what we call row operations. Has anybody ever seen matrices like this before? Never have? Anybody? Okay. What we're going to do, the first thing I'm going to do is in matrix operations, you can switch the rows. So I'm going to switch place from the top row and bottom row. So this top row I'm going to rewrite as 1, negative 2, 0, 0. And then the third row, the first row, I'm going to make the third row. So 4, 1, negative 2, negative 6. Why do you think I did that? I'm going to rewrite 2 just as is. Why do you think I did that? Do you remember reduced row echelon form? What was that number in the left corner, upper left corner? 1, right? It was 1, 0, 0, B, right? So having this 1 here is a step that makes it a little easier for me. The next thing we're going to do is change this 2 to a 0. So what row operation do you think we're going to make to change this to a 0? Okay, what we're going to do, I like to write it in terms of addition. So I'm going to put negative 2 R1 plus R2. And what that's going to do, that's going to change that second row. So the first and third row will stay exactly the same. And so here's the third row rewritten. All right, now, what's going to be negative 2 times 1 plus 2? Negative 2 times 1 plus 2 is?
4.
Negative 2 times 1, negative 2 plus 2 is 0. So you arrange that for that to be 0. And next we take negative 2 times negative 2 plus negative 3 is 1, right? That's going to be negative 2 times negative 2 is 4, minus 3 is 1. And then row 1 for both of these is 0, so we're just going to rewrite the rest of this as 3, 9. You see that? What in the way of logic do you think is the next thing we're going to try to work with here? Change.
The bottom.
The bottom two, negative 2.
Okay, what we're going to do is we're going to change this, we're going to get rid of this 4 and make it 0. What can we do in row operations to make this 4 0?
Minus 2, or negative 4, R1 plus R, no, R2.
So I think this is what you said, Jaden, here?
Yes.
Yeah, so Jaden's right about that. That's exactly what you do. Okay, so I'm going to rewrite rows 1 and 2 just as is.
Do you do the R3 because it's the third row?
Yeah, the third row. And I'm going to rewrite row 1 and row 2. Okay, and then next, what Jaden said is right. We take negative 4 times the first row plus the third row. And then we take negative 4 times 2, which is going to be 8 plus the third row, that's going to be 9. And then negative 4 times 0 and 0 is going to be 0, so we're just going to put negative 2 and negative 6 right here.
My brain hurts.
Yeah, it gets,
I don't like this.
you don't like this?
I think, I don't know, I think
It's
you
good
need
to
to give
use.
us a little bit. Well,
Yeah, what it said, it takes some time getting used to it, settle. Like I took a course summer before last in linear algebra, which helped. But what's the next thing we're going to try to get rid of?
The negative 2.
We're going to get rid of this 9.
Yeah.
Okay, what can get rid of this 9?
Negative 9, R2, plus R2.
Plus R3.
Oh yeah, 'cause it's on third row, yeah.
Yeah, so Jaden, I mean, Jaden's telling me what to do pretty well.
Yeah.
So I'm rewriting rows 1 and 2. And it may not look like it, but we're more than halfway to solving this thing right now.
Only halfway.
It's kind more than halfway.
Oh, yeah.
Yeah, I think it gets a bit tedious, right? So again, we take negative 9 times that, plus 9 is going to be 0, right?
Mhm.
And negative 9 times 3 is negative 27, plus row 3, that's going to be negative 29. And then the last one, what's negative 9 times 9?
Negative.
So negative 81 minus 7 is negative 87.
You mean minus 6?
Minus 6 is negative 87, yeah. Said it wrong. Yeah, but you see what I did, right?
Yeah.
What we did. Okay, now we just about solved for z. What can we do to make this negative 29 a 1?
Divided by negative 29?
Exactly, divide by negative 29. So we're going to go ahead and divide that bottom row by negative 29, and we get 0, 0, negative 29 divided by negative 29 is 1, and negative 87 divided by negative 29 is, it's actually positive 3. And then we rewrite this here, the same we have here, 0, 1, 3, 9. In the top row we have 1, negative 2, 0, 0. And so what we have is we successfully solved for z. Z is equal to 3. You see that?
Mm-hmm.
What's going to be our next thing that we're going to do?
Find the y,
Yeah, the y. So what do we have to get rid of?
the 3.
This 3 here. And so what are we going to do to get that 3 there?
Minus 3.
Okay, what we're going to do is we're going to take negative 3 R3 plus R2. Okay, and 0, 0, 1, 3 stay the same, and the top row stays the same. And now for here, we have that and that. What's going to be negative 3 plus 3 is 0, right? And then we have negative 3 times 3 is negative 9, plus 9 is 0. So now do we know what y is equal to?
1.
Y is equal to 0.
0, 0, 0.
Okay, what's the last thing we need to get rid of?
-2.
This negative 2. How are we going to do that?
Positive 2 R2 plus R1.
R1.
Sheesh, dude, my brain is killing me right now.
I
I'm a headache.
Yeah.
It's like a Rubik's Cube.
Do it carefully so you don't mess with another row.
So what we have is 1, and we got rid of this with the 0, and then this is going to become 0 and 0. So now do we have our solution?
No. Wait.
Yes.
Yes, we do.
Yes.
So we have our coordinate triple. It's going to be 0, comma 0, comma 3. Was it the same as the other problem we did earlier?
Oh, wow, that's gonna.
Yeah. But what it is, tomorrow what we're going to do is we're going to freeze frame right here.
Are you for serious?
And what we're going to do tomorrow is, somebody in 7th period asked me, what is the purpose of all this? Well, there are multiple purposes to this, but where we're going to go tomorrow is we're going to put these in our calculator and solve these in less than a minute.
Oh, we can do that the whole time?
Yeah.
Oh my gosh, Mr. G. You're killing me, Smalls.
You can like rate it. I think the calculator